practice on these three then. Get the hint, this might be important. Might even know how to do it. Just a little bit. Practice doesn't make perfect, it makes permanent. Perfect practice makes permanent. Hopefully I'm training you how to practice. You can go home and practice some more.
Do you need to have like the solids and the gases?
Yes.
I mean, do you need the label on that?
Yes. I did it on the last one. I left them off just for clarity. But yes, they're supposed to be there. You'll see me sometimes leave them off just so you can read whatever it is. Because my writing is so messy. All right, let's work them together, or else we got another section we still got to cover today, or else we might not get out of here. Okay, how many iron on the reactant side? 2. And on the product side, just 1. So I'm going to put a 2 right here. Oxygen, 3 and 2. How do I make 3 and 2 agree? 6 will get them to be the same on it. Because I can't make 2 into 3 and I can't turn 3 into 2, can I? But I can make both of them be 6, right? Everybody knows how to do that, right? Yeah. Lowest common multiple. So I'm going to put a 2 here and a 3 here. And what did y'all say? But then that messes up your iron. Yeah, it does. I have 4 over here, so I'm going to get rid of that and put a 4 here. It also messed up my carbon, didn't it? Here I have 3, so I need to put a 3 right there.
I have another question.
Yes, ma'am.
So when you put, what do you call the front number?
Coefficient.
The coefficient, and then you have the lower numbers, you have to multiply them together?
Yes, the subscripts. 2 times 2 means 4.
Anytime that you put...
Anytime I put it in front, it multiplies the subscripts. Because there's actually a 1 understood right there, right? So it multiplies.
So anytime you put a subscript and it has...
Anytime I put a coefficient, I multiply the subscripts by the coefficient.
Right.
So here there are 4 iron and 6 oxygens, right?
Yep.
Good question. Okay, next one. 1 aluminum, 2 aluminums. So let's put a 2 here. 1 iron, 1 iron. 1 oxygen, 3 oxygens. Okay, let's put a 3 here, but then that messes up my iron, right? So I'm going to put a 3 here. I don't care about smart response. Okay. 1 aluminum, 2 aluminums. Put a 2 here. What else? Sulfate. 2 sulfates, 3. How many hydrogens?
6.
6. 3 on this side. Now I have 6 hydrogens. 3 times 2 is 6. Okay? Everybody followed all of those.
Yeah.
Sort of see.
The last one I messed up on the sulfate.
I put a 3 here because there are 3 sulfates over here, right?
You follow the number on the outside.
On the outside, right? This tells me I have 3 of everything inside of here.
Because the SF4 is sulfate.
That is sulfate. That's right. Yep. See how I said you're going to learn some of those polyatomic ions because we use them a lot?
Yeah.
Sulfate, nitrate, or phosphate, those are all ones we'll use a lot. Okay? Make sense? A little bit? All right. What's that? Ms. Davis? No?
I said a little bit.
A little bit. Just a little bit. All right. Types of reactions. I love this section. Types of reactions. It's like one of my favorite sections of the whole book. Okay? Here we have a candle, right? and it's burning. When you see something burning, that's called a combustion reaction. And it's a special type of reaction. It's not the only type of reaction. Chemists like to classify things a lot like biologists do into different types of things. It makes it easier to discuss. You can talk about generalities, right? So for this discussion, we're going to have 5 types of reactions. I think of it as 4 plus 1. Okay, these 4 types here kind of go together, and then combustion reactions are different than everything else. So let's talk about these 4 types first. First one, combination reaction. A plus B comes together to make a couple, AB. Boy meets girl, they make a pair. Something new at the end, right? The couple is different than the 2 individuals, right? They do things different. Okay? So A plus B makes a single product. 2 or more reactants come together to make a single product. Now, what happens when you have couples most of the time? What happens to those couples? They break up, don't they? So when the couple breaks apart, that's called decomposition. When they come together, it's called a combination. When they break apart, it's called a decomposition. The couple breaks back apart into A plus B. You can think of this as the reverse of the first reaction, right? The first reaction was going A plus B to make AB. And now we have AB breaking apart, decomposition. Something's falling apart. Okay? Well, what causes most couples to break apart?
Another person.
Another person. Look at this. Here's my couple, and I got a single over here. What's going to happen? C's looking over there at A going, I like that A. A's a lot more fun than B was. So what am I going to do? I'm going to kick B to the curb, and then I'm going to be with A.
Yeah.
That's sad. Been there, done that, huh? Okay. So normally things don't just decompose. There was a reason they decomposed. This is called a single replacement reaction. I have a single thing replacing something else in the couple. Because somebody got wandering eyes. Well, had that couple been a modern progressive couple, they might have tried something like this.
Oh my God.
Wife swap, right? No? To each his own, right?
Yeah.
We're not going to judge you. Instead of kicking you to the curb, I'll let you go with their partner. We'll just swap partners. We're now doing a double replacement reaction, okay? So we have 2 couples and they swap partners. Now, students often say, well, what happens over here? Why does this reaction occur? Well, if you look over here, one of these couples over here, this isn't like swingers where they can just go back and forth, right? To go back to their original spouse. It's not quite that way. No, we shouldn't use that term. What happens over here? Look right here. This one's a solid and this one's a gas. This new couple that was formed over here was really strong. So they stayed together forever. And then these 2 guys were just like kind of left hanging out. They're like, well, I got nobody else. Might as well stay with you. Or in this case, this one formed a gas. What happens to gases? They bubble and they leave. Hey, I got my new partner. We're out of here. And these 2 guys are just left hanging out. Poor guys. Got nobody else. Might as well hang out with you. That's it's terrible analogies, aren't they?
That is terrible.
Double replacement. Okay? There has to be a reason for it to swap. Now, students also ask, how do you know who you're going to get in a partner over here? How did I know that A was going to go with D and C was going to go with B?
Instead of A with C,
Yeah, why didn't A go with C?
does it have to do with the balance?